Hey class, welcome back to our lesson today, exponent rules using literal bases. So we're just going to go do a little bit of review, just as a review of terminology. When we talk about a term, we're talking about this entire term here, right? When we have this entire a to the power of n, right? We're going to call that a term, right? This n we're going to call our power or our exponent. And then we're going to call this a our base or variable. So this is just a review from before, right? Normally this a is a number, but in this for our purposes today, this base might actually be a letter as well, right? But we're still going to treat it the same way we do with numbers. Alrighty, so we're just going to move on. So a few things to remember. When you're multiplying powers, what you're going to do is when you're multiplying exponents, you multiply the coefficients. So you're going to take the 5 and the 2 and multiply those two together. And then you're going to add the exponents on the same base, right? So you'll notice that these are not like terms. But because there is this multiplication sign in the middle between them, we can actually do something about it. If this was 5am plus 2an, right, because it's a plus, or if it was a minus 2an, you would just have to leave it together. But because it's a multiplication, we can do something about it. So we can do 10 times 2, which is, 5 times 2, which is 10. And then we can do a, because this is the same base, we can just add them together, am plus n. And that's going to give me 10 am plus n, and then whatever m plus n is, if it's 1 plus 2, whatever it might be. So let's do that following the rules above. We know that we have 1x multiplied by 1x. 1 times 1 is going to be 1. X times x is just going to be x1 plus 1, right? So we're left with x squared. So same thing here, if you have 2x times 1x, you have 2 times 1, so we're just going to multiply the coefficients, and then we're going to multiply the exponents, and it's going to be 1 plus, add the exponents because we're multiplying the variable, so it's 2x squared. And remember, this only works if you're multiplying, not if you're adding and subtracting. So try these 3, 4, 5, and 6 on your own, 7 and 8 on your own. I'm obviously going to take them up, but just pause the video and go through it yourself, and then you will come back and watch this video and make sure that you know how to do them. Okay, so welcome back. So if you have 2 times 5 here, you can do 2 times 5. So I'm just writing this out. You obviously can just do this in your head like I've been doing. 2 times 5, and then you have x, 1 plus 1. So you have 2 times 5 is 10, x squared. Okay, then you have 2 times 1, because this is a 1x, right, in one bracket because you're just multiplying the coefficients together, and the x squared times x. 2 times 1 is just 2. If you're doing multiplication of two coefficients, of two variables, you're just adding the exponents together. So 2 plus 1 is 3, so it's 2x cubed. Same thing here, negative 3 times negative 3. A lot of you on your test had written negative 3 times negative 3 is 6. 3 times 3 is 9, so it's just make sure you get that right. And then you have x to the power of 1 plus x to the power of 2, right? Because you're multiplying coefficients. So just make sure you're careful with the 3 and the negative 3 and the negative 3. So if it's a negative 3 and a negative 3, you need to make sure that you remember that a negative and a negative will always give you a positive. So you're left with positive 9. And then you're just going to add the exponents together. So exponent 1 plus 2 is going to give you x to the power of 3. So you're left with 9x cubed. Here you have a negative 1, right, because it's negative x, times 4, because those are two coefficients. Then you're left with x squared. And this is a 1, so plus 1, right? And then you're left with negative 4x. 2 plus 1 is just 3. Right? And then if you go down here, same thing, right? Take two coefficients. Let's just take the two numbers and multiply them together. -2 times -8. And then the two variables, because they're the same, we're going to multiply those together. Right, so you have -2 times -8 is going to be positive 16, because it's a negative times a negative. And then 3 plus 5, because it's multiplied by. So you're left with 16, 3 plus 5, x to the power of 8, and that's your answer. And then, last but not least, you have 2 times -3, x times y. Can I, after I do the 2 times 3, because I can still multiply the coefficients, I'm left with -6, and then I have x times y. Can I add these two exponents together? No, because the bases are different. So it's just going to be -6 xy. So you don't add the exponents together on bases that are not the same. So that's something important to remember as well. That seems to be a common mistake a lot of students make. Just be careful with that. Okay? All right, so we're going to move on to dividing powers. So rules for dividing powers. Right? When you're dividing powers, you divide the coefficient and subtract the exponents on the same base or variable. So you're going to do the numerator's exponent minus the denominator's exponents, and then you're just going to divide or simplify in the situation these two terms, right? The coefficients. So 5/2 is already the most simplified that it can be, and then you're just going to do 5/2 times am minus n. Right? So I'm just going to put them to the... Remember, those are exponents. So let's try to do that. Here we have 1x and 1x. That's just going to leave us 1/1 is just 1, so we'll leave that alone. And then you have x5 minus 1, because this is a 1. So you have x5 minus 1, so you're left with x to the power of 4. Okay? Here we have -12 divided by -4, which we know is going to be +3, right? And then you have x9 minus 2, right? So 3x9 minus 2 is going to be 7, so you're left with 3x7. So try doing 3, 4, 5, and 6 on your own. One thing I would remember is that here you're only dealing with the same exponents. So if you have p's, only reduce the p's. If you have q's, only reduce the q's. Okay? And now just come back and listen to the recording. So here we have 45 over -45 rather over -45k to the power of 7 divided by 15k to the power of 4. Let's just deal with the coefficients first. Let's do -45 divided by 15. We can reduce that to -3/1, which we can write it in if you want. Right, and then I know I have k over 4, or k to the power of 7 over k to the power of 4. So I know when I'm dividing, I'm just going to subtract the exponent. So I'm left with -3, leave the 1, you don't need to put that in. 7 minus 4 is going to give me 3. So k to the power of 3, that's my answer. Okay, now number 4 is a little bit more complicated. Same approach though. Let's go and figure out, okay, what's 36 divided by -4? So 36 divided by 4 is 9, and since they're both, it's a positive and a negative, it's just -9. Then let's go deal with our m's. Our m is m. We have a 5 at the top and a 1 at the bottom. So we're just going to do m5 minus 1. Now, n, let's deal with the next variable that we have. We have n to the power of 12 and n to the power of 7. So let's do n 12 minus 7. Right? Now everything's kind of in one line, so we can just solve. So we'll do 9, we'll leave that as is. 5 minus 1 is going to be m to the power of 4. And then n 12 minus 7 is just going to be 5. So that's our answer right there. Okay. So try doing 5 and 6 on your own. and hopefully that makes a little bit more sense. And then even try doing 7 and 8 is a big one, right? So if you get 8, I think you kind of understand how to do these divisions. Okay, so pause this video, try doing them, and then we'll come back and take them up together. Alrighty, so welcome back. So we're just going to go over and take up 5 and 6. Hopefully you had a chance to try these on your own. So again, we're just going to start off with reducing our 8 over 6. Since you can't divide it and it'll give you a decimal number, we're just going to reduce it. So 8 over 6 can be reduced to 4 over 3. So I'm just going to go back, write that, oops. So I'm just going to write 8 over 6, right? I'm just going to see this as, another way that you could look at this is you could see this as 8 over 6 times P15 over 7, P17, or P7, sorry, over P7. So you're just breaking them up into smaller parts, right? Because it basically means the same thing. All right. So let's just reduce it one by one. So let's deal with our 8 over 6 first. So I know if I take my 8 over 6, I can reduce this to 4 over 3, right? Then I can do my P15 over 7 because they have the same base, right? So I can do 15 minus 7, so I'm just going to put that in blue. P15 minus 7. And then my last but not least, I have my Q's. That's also the same base, so I'm going to do Q 6 minus 3. So I have 4 over 3. 15 minus 7 is going to give us 8, P8, and then Q minus 6 minus 3 is going to give us 3, so that is my final answer. Cool. So the easiest way to do this is just break them up and like how many parts do I have? What are the same bases? So always break it up as, okay, what's the first thing I have going for me here? I have 4 over 18, negative 4 over 18, which is the coefficient, so let's break it up. Then I have these x's that have the same base, so I'm going to do times the x bases. Then I have these y's that have the same base, so I'm going to do that. Right, and then let's just break it up and go step by step. So I'm going to do 4 over 12, 4 over 18. I can divide both by 4, or by 2, right? And I'm left with 2 over 9, right? Multiplied by x, and I'm just going to put that in blue again, x4 minus 4, right? Because I'm going to do numerator and denominator. And then I have y 5 over 3 times y 5 minus 3, right? So I'm left with negative 2 over 9. X4 minus 4 is just going to be x to the power of 0, so we'll just cross these out. It'll just be 1. And then we'll be left with the y, which is going to be y. 5 minus 3 is 2, so it's y squared. And that's my answer. Cool. So that's 6. Moving on, you have x to the power of 9. And I'm just going to draw this out for you. So let's just do it. 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to add the last 9 up here. Right? And let's do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. They all cancel out, which means I'm left with 1. Another way for us to see this is x9 minus 9, x to the power of 0. Anything to the power of 0 is equal to 1. Okay? And that's how I would find that answer. Then we're going to move on to 8 over here. So 8 is saying that it's negative 9, x to the power of 7, y to the power of 4, z to the power of 12, right? All over 18, x to the power of 5, y, z to the power of 11. So again, if we just break this down into the different components that it has and the different bases, it just becomes a lot easier. So let's break it down. I'll do this in black here. Negative 9 over 18 multiplied by x to the power of 7, x over 5, multiplied by y to the power of 4, y, multiplied by z to the power of 12, divided by z to the power of 11. Right? And now let's go solve each of these individually. Let's deal with the 9 and the 18 first. So 9 divided by 18, right? If I reduce that, I'm just going to get negative 1 over 2, because I can divide both by 9. Multiplied by, let's go deal with x to the power of 7 divided by x to the power of 5. Since they're both the same base, we can just subtract the exponents. Moving on, let's go to this one, y to the power of 4 over y, just y minus 4, y to the power of 4 minus 1. And then again with the z to the power of 12. And we can take the z and add that in. So we multiplied by z, and you're going to take the numerator minus the exponent of the denominator. Then we're just going to go in and simplify. So negative 1 over 2. x7 minus 5 is going to give us squared. Y, 4 minus 1 is just 3. And then 12 minus 11 is going to be 1. Right? So it's going to be z 1. So I'm just going to get rid of that 1. You don't need to write it in. Right? And this is the most simplified form. So if you're going to do something like this, how I always recommend you go through it, especially when it gets to more complicated problems, I highly recommend just breaking them up by base by base by base. Right? So do coefficients, and then if you have 3 bases, break it up in 3 bases, and then just write it in. Okay? All right, moving on. So when you have a power to a power, right? So if you have this and then it's to the power of m, everything inside, you're just going to apply that m to everything inside. So you're going to apply it, it's going to become 2m, right? 2 to the exponent, as well as 2n times m. Okay, so let's just try to do that. In this one, it's pretty easy. You only have an exponent, so on a variable, so we're just going to take the 2 exponents, 7 times 6, right? We know that 7 times 6 is 42, so it's x to the power of 42. And that's my first answer. This is where it gets a little bit more complicated. Because you have a coefficient, you need to take to the power of 6 to both the coefficient and the variable. So it's x times 1 to the power of 6, x to the power of 1 to the power of 6. So you're going to do negative 2 to the power of 6, which if we put it into our calculator is positive 64. And then we're going to do x 1 times 6, right, because it's to the power of 1 times 6. It's going to be 64x to the power of 6. And that's our answer. Same thing here. We're going to do negative 2, right, and we're going to do that to the power of 3 because we're just going to distribute it to everything. And you can do x to the power of 3. So then you have negative 2 to the power of 3 is negative 8x cubed. Okay. Now this is where it gets a little bit more complicated, so watch me. You're going to apply it to the 3. So it's going to be 3 to the power of 3. And we're always going to put ours in brackets. You're going to apply it to the x, so it's going to be x to the power of 3. And we're going to apply it to the y squared to the power of 3. And now let's just go in and simplify these each on their own. Let's simplify the coefficients first. 3 cubed is going to be 27. X cubed is just going to be x. 1 times 3 is 3. And then y squared to the power of 3 is going to be y 2 times 3. And then if you're going to simplify that, it's going to be 27. And make sure that you multiply here. A lot of you were adding, even though if it was a power to a power, you need to make sure you multiply 6. Okay, and that's my answer. So I'm going to have you try to do 5, 6, 7, and 8 on your own, and then we can take them up together. So just pause this video, go through it by yourself, and then I will go through and we'll solve all the rest of them. I'm going to teach you how to do 0 power exponents. Then we're going to do some all mixed up ones. I'm just going to answer those questions. Obviously, try to do them by yourself first, right? And then we'll go from there. Okay? Alrighty, let's get started. So hopefully you pause the video and you're coming back to this one. So here, we're going to take that 3 and we're just going to put it in everywhere. So it's going to do negative 3 to the power of 3, right? X to the power of 1 to the power of 3. Y to the power of 2 to the power of 3. Very similar to this one, except now it's negative 3, right? So negative 3 to the power of 3 is negative 27. So we're just going to start here. Let's start off with the pink, negative 27. Then you have x to the power of 1 times 3, which is going to be x to the power of 1 times 3, which is just 3. If you want to write that in, you can. And then you have y squared to the power of 3, y 2 times 3. Now let's quickly simplify and do negative 27, x 1 times 3 is just 3, y 2 times 3 is 6. So that's our answer. Okay, and you obviously don't need to use different colors. I'm using it so that you understand what I'm doing. Now here we have a negative x squared to the power of 2. So we're going to do negative x 2 times 2, right? You're also going to apply it to the negative 1. So this will be negative 1 squared, and then x squared, right? So negative 1 squared is just 1. X squared is x4. So we have 4 power, x to the power of 4. Okay? Alrighty then. Now if we move on, we have this 2 over 3, right? So let's do that, and that's going to be to the power of 3 because we're going to distribute it in. And then we have x 2 to the power of 3. Now, when we're doing a power over a fraction, you actually apply it to both. So it's going to be 2 squared cubed, and then you apply it to the bottom. It's also going to be 3 to the power of 3. Okay? And then you have your just x squared 2 times 3, which is just going to be, so 2 cubed is 8. 3 cubed is going to be, 3 times 3 is 9, times 3 is 27, right? X 2 times 3 is going to be x to the power of 6, and that's our answer. Okay? And then last but not least, first you're always going to go in and use BEDMAS. So first you got to do brackets. We have no brackets in this situation, so we're going to move on to exponents. So let's do the exponents first. You have x 7 times 3. Then you have negative 3 cubed. We're just going to put that in a bracket. Negative 3 cubed, x 2 times 3, right? And now we're going to go back and do that bracket first. So let's do that. Negative 3 cubed is negative 27. X to the power of 2 times 3 is 6, right? And then outside we have this bracket, which is x times 21. And now we have x times 21. X to the power of 21 times negative 27, x to the power of 1. So let's just look at the coefficients. We have negative 27 and then just 1, right? So our coefficient will be negative 27. And then we have here our x to the power of 21 and x to the power of 6. They're multiplying by each other, so they're going to be x to the power of 21 plus 6, right? Which is going to give us negative 21, x 27. Or sorry, negative 27, x 27, because that's a negative 27. So, when you have 0 exponents, when you have an exponent to the power of 0, the variable that the exponent is on is equal to 1. So, if we have it here, a to the power of 0, this entire thing is equal to 1. Here, we have a to the power of 0 times negative 1, so this will be negative 1. And then here we have negative a to the power of 0. Everything is to the power of 0, so it'll be positive 1 as well. Okay? So let's just do this. 5 over 5 cancel each other out, so this is going to give me 1. 10 and the 10 cancel each other out, so that's going to give me 1. The x and the x cancel each other out, so that's also going to give me 1. So my answer here is 1 times 1, which is going to be 1. x10 minus 10, x to the power of 0, 1. And those are my answers. So if there's no exponent, then the exponent is equal to 0. It's equal to 1. Okay, so in this situation, there was no exponent, so it's 10 over 10, x1 over x1. So you did x1 minus 1, x to the power of 0, if you wanted to see it that way. I personally never look at it that way, but it's up to you if you want to. So here, we have 2x to the power of 7 to the power of 0, right? That's just going to be positive 1. We have negative 8x to the power of 0, also positive 1. Then here we have negative 1, right? Because the 0 doesn't apply to the negative 1. And then we have 8, and the 0 applies to the 8. So let's just deal with the negative 1, leave it alone. And then we have the 8 to the power of 0, which is 1. Negative 1 times 1 is going to be negative 1. Okay? Here we have p to the power of 1 times p to the power of 3 times p to the power of 5. Since we're just multiplying, we can just add all of these together. So p 1 plus 3 is 4 plus 5 is 9, so it's p to the power of 9. Okay. Moving forward here, again, let's just break this up. Let's do the coefficients, right? We have 3 and 6, so we'll do 3 multiplied by 6. Then we have a and b, so we'll go and put that in the blue. So then we have a to the power of 1 times a to the power of 3. And then last but not least, in green, we have this blue, right? So we have b to the power of 2 times b to the power of 4, right? So let's just go in and solve this. 3 times 6 is going to give me 18. A to the power of 1 times a to the power of 3 is just a1 plus 3, which is going to give me 4. And I'll write that in case you're wondering where I got that 4 from, because we're just going to add the exponents together. They have the same base. And then we have b, 2 plus 4, right? And then I'm just going to go and solve it. 18, a4, b6. And that's my answer. Here, this is where this gets a little bit complicated. How I like to look at this is always look at the numerator and then look at the denominator. I'm going to solve it together, but it's up to you. Make sure you solve the numerator first, then the denominator, then go on and simplify. So let's just deal with the numerator and the denominator first. So here at the top we have 3 times negative 8. So let's go deal with that. 3 times negative 8, right? And then we have the x squared times x to the power of 6, right? And then that's all over, and I'm just going to put this in brackets up here so that we know it. That's all over. Let's go and take the coefficients from the bottom. 2 times 7, and then the variables at the bottom are x5 times x squared. Right, and now let's go simplify. Let's just go do this. 3 times negative 8 is going to be negative 24. 2 times 7 is going to be 14, right? Then we have left over x2 plus 6, x5 plus 2, right? And then that's negative 24 over 14. X2 plus 6 is x8 divided by x5 plus 2 is x7, right? And now let's just simplify. Let's simplify our first number, which is going to be 24 over 14. We can simplify that by dividing both of them by 2, so we'll get negative 12 over 7. And then x8 minus 7, because it's division, so we have negative 12 over 7. 8 minus 7 is x to the power of 1, so we'll just leave it as x. Okay? And that is that. Okay, now moving on. Try doing 8, 9 on your own, right? And then your exit ticket will actually be your exit ticket. submit these into your portfolio. I might put this under your assignments page. So I'm going to have you put these under your assignments page, and it'll be under assignments, exit ticket 2. Okay, as a PDF, please. So just submit it under your assignments as a PDF. It's a great way to get feedback, so just make sure that you do it. All right, so you can come back to this video and just watch me take out these. I will also, after you submit 10, 11, 12, 13, and 14, and 15, you will actually be able to see the results for it and the video for it as well. So I will make that submission so that you can see and take it up by yourself. Okay, so here we have negative x squared, all to the power of 3, right? So first let's deal with the negative x inside the bracket, right? So we have negative x, so we have negative 1 squared, x squared, right? And this is all to the power of 3. So let's just deal with what's inside first. Negative 1 is just going to give me 1, so I'm just going to leave that, and we're going to write that as an x squared. All of this to the power of 3, right? Now, let's look at the x. When we have a power to the power, we just multiply. So we have x to the power of 6, and that is my answer. Here, we're going to distribute this 3 into everything. So it's going to be negative 3 times to the power of 3, m squared to the power of 3, and then n to the power of 5 to the power of 3. So you need to make every term inside of there, or every variable inside of there, to the power of 3, right? So we're going to do negative 3 to the power of 3 gives us negative 27. M squared to the power of 3, because it's a power to a power, you're going to multiply the two powers together. Same thing with the n. So we have negative 27. 2 times 3 is 6. N 5 times 3 is 15. And that is our answer, right? You can't simplify that anymore. You can't collect any more terms. Okay, and the same thing here. So we have 25 over 5. So I like to write this as 25 over 5. And then I like to write multiplied by k to the power of 4 over k to the power of 3, right? So I have 25 over 5. I know that's going to be 5. 25 divided by 5 is 5. And then I'm going to do k, 4 minus 3, 5k to the power of 1. So I'm just going to leave it as 5k. Okay? All right. So that is it. Try doing 10, 11, 12, 13, 14, 15, 16 on your own. And then that will be your exit ticket number 2, and we will take that up tomorrow.